Hi there. In this video, we're going to look at solving proportion problems. And we're going to use 3 different methods. So you can kind of try each one and see which one makes the most sense to you. And then in different situations, you might want to use different methods as well. Okay, so I've got 3 different problems. The first one is a car speeding on the highway in cruise control travels 18 miles every 15 minutes. Okay, and this cruise control is meaning it's on automatic, so it's going to stay a set speed. So this is telling us it's going to be proportional, right? Same rate. How far will the car travel in 5 minutes? How far will it travel in 1 hour? Okay, 5 minutes and 1 hour. So this method is solving proportion problems visually, or another word for this is scaling. So I've got a bar drawn out because if you're visual like me, it can help to have a visual. So I've got a bar going across the whole page, and then I've got 0 miles and 0 minutes on the left, miles on the top, minutes on the bottom. And then 18 miles corresponds to 15 minutes because it says the car travels 18 miles every 15 minutes. So about partway over, I've got 18 miles and 15 minutes. Okay, so now we want 5 minutes. So to get 5 minutes, I need to look at the minutes, which I have on the bottom of the bar. And I need to think, how do I go from 15 to 5? Well, if I count by 5s here, I can go 5, 10. So 0, 5, 10, 15. So I'm really cutting that down into thirds, right? Because 5 is, there's 3 5s in 15. So if I can do the same thing with 18, which I can, and you might not, if you're not sure, that's fine. You can use your calculator. 18 divided by 3 is 6, or 6 times 3 is 18. So if I count by 6s, 6, 12, 18, then that works as well. So that tells me that in 5 minutes, the car will travel 6 miles, right? So let me write that out. The car will travel 6 miles in 5 minutes. Okay, so that's one way to do it. And then this one had another question. How far will it travel in 1 hour? Okay, so we're talking about time again, 1 hour. So now I need to think about 15 minutes and 1 hour. Okay, so 15 minutes is a quarter of an hour, right? On the clock, 15 minutes. So I need to do that 4 times to get up to 1 hour. So now I'm going to scale bigger. First time we scaled smaller. Now I'm going to scale this 15 minutes bigger. So if I can do this 15, I'm just going to estimate to the right. That's a 1 time, then a 2nd time, a 3rd time, and a 4th time. So 15 minutes, 30 minutes, 45 minutes, and then either 60 minutes or 1 hour. Either way is fine. So the original is 15, and then I go 30, 45, 60. And then same thing with the 18. Now I need to count by 18s. I'm not as good at counting by 18, so I'm going to use my calculator. 18, you might be going, well, you can just multiply it by 4, right? That's fine. I'm just going to fill in my whole chart. So 18, I could do times 2, or I could do 18 plus 18 is 36. I'm going to do plus another 18 to get 3 times is 54. And then plus another 18 is 72. Okay, so this car is speeding a little bit. We're going a little bit fast, huh? Or you may have noticed you could go 18 times 4 and also get 72. Okay, so then I'm going to say the car will travel 72 miles in 1 hour. You might recognize that also as 72 miles per hour. That's the rate. Okay, so that's called scaling or using a visual method, and you're welcome to use that if you like that method. Let's look at another problem and use a different method. Okay, second question. on this page is bars of soap are on sale at the price of 3 bars for $2. How much would you pay for 7 bars of soap if the sale applies to all quantities at the same rate? Okay, so again, to solve this, we need to know that the rate is the same. Otherwise, we wouldn't be able to do it. So I'm going to do this one with a unit rate, kind of like the cans of chickpeas before. So I like to think about, okay, dollars per can, in this case, dollars per bar. So I'm going to figure out what my unit rate is going to be first. My unit rate, and I'm just going to use the units first, dollars per bar, okay? And then I use that to decide where to put my numbers. So let me change colors. So in this case, it would be $2 for 3 bars. And now I'm going to divide that on my calculator. 2 divided by 3, or you could recognize that's 2/3. 0.67, because it's money, I'm going to round it at 0.67. Be 67 cents. 67 cents per bar. So I'm going to putting the dollar sign with 0.67 per bar. You may know that if you want to use the cent symbol, then you wouldn't use the decimal and you would put the cent symbol after. So this would be the same as 67 cents with the cent symbol per bar. Okay, now we haven't finished solving the problem yet, right? Because we know the unit rate, but the question is, how much would you pay for 7 bars of soap? So I bet you can guess what to do next. To get 7 bars is going to be 7 times the 67 cents per bar. Okay, and if I write 7 bars here, which I should have done, if I write 7 bars, then my units will actually cancel out, and you'll see we're left with dollars, and that's what we want. So 7 times 0.67 is $4.69. Okay, so I would answer my question. I would pay $4.69 for 7 bars of soap. Now, if you were doing this yourself, oops, sorry, let me raise it up. If you're doing this yourself, you may have gotten a slightly different answer. So let me show you. Remember how I rounded the 0.67? Let's do 2/3 again. And that's a repeating decimal, 0.6666, and the calculator rounds the very last digit up to a 7. Let's say I hadn't rounded that off, and now I went ahead and multiplied by 7. I get 4.67. So it's a slightly different answer, right? Depending on when you round. So that's why you show your work, okay? I'm guessing the store would go ahead and round the unit price, but I don't know for sure. Maybe you have worked in retail and you know. I would accept either of those answers. That's why you show your steps, and then that would be clear how that happened. Okay, so that is the second way. And remember how we talked about on our definition page that with a proportion, one quantity is a constant multiple of the other. Okay, so in this case, we've got each bar of soap is 67 cents. That's our constant multiple or unit rate. Okay, great. So let's do a third one, and then I'll also come back and apply these other methods to the other ones as well. Okay, now you might be thinking of one that I haven't done yet that you've seen before, and that's solving a proportion with an algebraic equation. Okay, so if you like to do questions this way, you're totally welcome to. A house valued at $480,000 has property taxes of $4,992 per year. Okay, so we've got a rate. In the same neighborhood, assuming the tax rate is proportional, what would the property taxes be for a house valued at $395,000? Okay, notice in all these, we're given 3 numbers and we need the 4th. We're trying to find the 4th one. So this really lends itself to an algebraic equation. Again, I like to put the smaller one on the top, but it's up to you because you can flip the whole thing upside down. 4,992 in taxes over the 480,000, 000. So what I'm doing is I'm putting the tax over the total. And if it helps to write that out, you can definitely do that. Then I'm going to set that equal to, and I'm going to put the other house in my second fraction. So what am I looking for? Is it the taxes or the total? Well, I know the total house value, so I'm actually looking for the tax. So I'm going to use an x, a variable for that. You could put a question mark. You could put, since we're using algebra, I'll use a variable. And we know that our house value is 395,000. Okay. So if it's been a while since you've solved an equation, when we have a variable, we want to isolate that, right? We want to get it by itself so that we know what that is equal to. So when I have a division, I need to do the opposite operation to isolate the x. So if I multiply this by the 395,000, that will cancel out or undo each other because multiplication and division are opposite operations. Now I need to do the same thing on the other side because an equation is a balance, it's a scale, right? So if I do one thing on one side, I have to do the same thing on the other side. I don't quite have as much room as I want here because I wrote the words, but I'm going to put it up above here. 395,000 times, okay? So that tells me what operation I need to do. I need to multiply these two numbers. These are going to undo each other, and I can do that on my calculator. 395,000 times 4,992 divided by 480,000. And I got $4,108. Okay, I want to check and make sure that's reasonable. Does that fit with the proportion? So the house value is slightly less, 395 versus 480. And so the taxes should be slightly less as well because they're proportional. And so that does seem about right. Okay, so I'm going to say the house valued at $395,000 would have property taxes of $4,108 per year. Notice that this tax rate is a rate, but we're just talking about 1 year. So the rate didn't really come into our calculation at all, but there's a tax rate, and then there's also, well, yeah, that's the tax rate per year. There's a tax rate, and then that's per year. So there's two rates. Okay, great. So I'm also going to go back and try some of these other methods on the other problems, okay? So if you want to try that, pause the video and then come back. Okay, but I'm going to go back up to our speeding problem and see, I'm going to try, let's say we want to do that one with a unit rate, the second method. We do that one with the unit rate and miles per hour. So we did come up with a unit rate, but I'm going to go back to our original information we were given, miles per minute. So I'm going to do miles per minute because we had 18 miles over 15 minutes, or 18 miles every 15 minutes. So let's see what that is as a unit rate. 18 divided by 15 is 1.2. So that's 1.2 miles per minute. And sometimes miles is abbreviated MI. Okay, miles per minute. Okay, so if we get that, then we can answer the other questions, right? So we can say, how far will the car travel in 5 minutes? Then we multiply that by 5. Wait, is that right? 5 minutes. I don't think that's right. Let me pause it. Okay, sorry, that was right. You know, we all make mistakes, but I was right. And you can tell if you actually helps if you write out the units. That will help you know if you're doing it right. So if I had written 5 minutes times 1.2 miles per minute, then I would have been more confident because I would have seen that my minutes cancel out and miles is the answer that I want. Okay, and then when I do 5 times 1.2, that is 6 minutes, and that's the same thing we got there. Okay, so you're welcome to use a unit rate on this one as well. And then let's try this one with a proportion. Let's see if I can squeeze it in here. Let's try a proportion on this one. So then I would have said, I'm just going to keep the same miles per minute. I'm going to keep the same order since miles is on top. We could have 18 over 15 equal to, let's try the 1 hour this time. So equal to x out of 60. Because this is in minutes, I'm going to keep 60 minutes. And then I would need to multiply by 60 on both sides. And x is going to equal 60 times 18 divided by 15, and that's 72. I'm going to say miles. Oops, I see I did mess up my units right here. It should have been 6 miles. Okay, so we did all 3 methods on that one question, so any of those work just fine. So you're welcome to do any one you like, or maybe even have a different way. Just show your steps. That's what's really important, is to show your thinking. Okay, so let's try this bar of soap. We did it with a unit rate. Could we do it the visual way? I don't know. Let's see. Let me try drawing a bar. So I'm going to draw a horizontal bar over here. And then we had 3 bars for $2. So I'm just going to go 1, 2, 3. So we have 3 bars. And we have $2. Maybe I should have switched those. 1 on the top, 1 on the bottom. And then we want 7 bars. So I've got 1, 2, 3. I'm going to go 4, 5, 6, 7. So 7 bars. Okay. Now this one's a little harder to scale, right? Because it's a fraction. It's not a whole number. So I could maybe I do 3 over 2 and say every 1.5 is 2. Every 1.5 is, that was harder for me. I'm going to do 2 divided by 3 like we did before. So every 2/3, every bar is 2/3 of a dollar. So it's kind of like scaling like we did before. Every 2/3, and we have 7 of those. Every 2/3 is a bar of soap. So 7 times 2/3 is that 467 we got. But remember, when we rounded it as 0.67 per bar, we got 469. So either way is okay as long as you show your work. And then what if we did a proportion for this one? Let's say I'm going to go back to the dollars on top because that's easier for me. $2 for 3 bars. And that's equal to, we want to know how much, right? So x over 7 bars. Okay. One thing I'll say about the proportions is it is easier if your variable's on the top, because then you multiply by multiplying each side by a constant. So if you end up with your variable on the bottom, you can just flip the whole thing upside down. That's one option. Or you can solve it with algebra as well. It just takes a few more steps. So then I have x is equal to 7. You're seeing it's the same calculation, right? 7 times 2/3. $4.67. Okay, so I hope you're seeing that you can use any of these methods interchangeably. And then back to our tax question. This one I probably would not try to do visually because I think the numbers are so big, it would just be challenging. So if you have something that has smaller numbers and it has like a whole number rate, I think that's a better time to use the visual method. But you can use the unit rate or the proportion at any time. So let me try this one with a unit rate. Okay, unit rate. So whenever I do unit rate, I want to think about my units, or actually this one's more like a ratio, but it is, I'm going to put the tax, and I wrote it over here, the tax over the total. So I'm going to put the smaller over the larger. The taxes, so I'm going to put the 4,992 over 480,000. And to remind myself, I'm going to remind myself that that's the tax over the total. Okay, so that is, let's see what that unit comparison is. 4,992 out of 480,000. That is 0.0104, 0104. Okay, so that is, this is money, right? So we're in money. So this is like well, actually this is a percentage. This is like it's like a 1.04% in taxes, because I was just remembered that they're both money. So the money has canceled out, and this is like a percentage that you're paying in taxes. So then I'm going to apply that percentage to the 395,000. So I'm going to multiply that. I'm going to keep it in the decimal form because we always need to do math with the decimal form. Let's see if we get the same number. 395,000 times 0.0104, and we get $4,108 in taxes for the larger house. Okay, so we got the same thing. Okay, great. Thanks for watching, and I'll see you in the next video.